All right, let's dive into graphing quadratic functions. We're really getting into the meat, the foundation of chapter 5. All right, so a parent function for a quadratic is just y equals x squared. If you remember back to your Algebra 1 days, you were probably asked to make a table using -2, -1, 0, 1, and 2. You plugged it into your equation, being careful that your negatives had parentheses around them. You got 4, 1, 0, 1, and 4. You made a pretty little graph. And it probably looked something, hopefully, like this. Okay, that is our parent function, okay? One of the tricks with using our parent function that we'll use throughout this chapter is if I go over 1, 1 squared is 1. So I go up 1, 1 squared is 1. If I go over 2, 2 squared is 4. And the reason we're, again, using that is because we are dealing with a quadratic function. So I'm always squaring things, okay? Now, our vertex formula helps us out a lot. It is written as f of x is equal to, we have an a on the outside, x minus h being squared plus k. All right, the big thing to pull out of here is the vertex. So when we're talking about a parabola, our vertex is going to be that turnaround point. So in a parent function, it's at 0, 0. When I pull it from my vertex formula, it is h and k. So you'll notice there was a negative sign in there. When I pull it out, it's still positive. When I take it from the k, it's exactly as is. Okay? Some other general reminders is that a value out in front. If it's positive, the parabola opens up. If the a value is negative, our parabola opens down. All right, if we start talking about our a value changing, like what does it do if it's a different number? If the absolute value of a is greater than 1, it becomes very narrow. So like if you have a 3 in there, or if you have a 4 or a 10 even. But if the absolute value of my a is less than 1, think fractions like a half, a fourth, a third, things like that, then the parabola becomes really wide. So those are some big ideas we're really going to be hitting this chapter, okay? If your parabola is not in vertex form, so you can't just pull the vertex right off the bat, you need to be able to find the vertex, and that is using the formula x equals negative b over top of 2a. Okay, and again, when it's in our form, our standard form, here's your a, here's your b, and here's your c, and we will practice that today. Okay? All right, so let's start by graphing these two things. Okay, so we have y equals x squared, our parent function, and then we have y equals x squared plus 3. So I'm going to make myself a little graph over here. I am hoping your parent function comes really quick. So again, 0, 0, over 1, up 1, because 1 squared is 1, over 2, up 4, 1, 2, 3, 4. And then we just have the mirror image on the other side. And we play connect the dots. All right, if we look at this second one, x squared plus 3 on here, this plus 3 is outside the parentheses. So what we need to remember from our Algebra 1 days is that means it moves up 3 spots. So essentially all I'm going to do is take this vertex that was at 0, 0, I'm going to move it up 3, 1, 2, 3, and put my new vertex up there, okay? With my new vertex being located up there, nothing else about the graph has changed because there's nothing out in front. I don't have parentheses, meaning it's moved or changed any other way. So with my new vertex at 0, 3, I'm going to go over 1 and up 1. Again, I can do its mirror image. And then I can go over 2 and up 4. 1, 2, 3, 4, and put my new dots and the mirror image. Connect the dots with those, and you've got your two pieces graphed. All right, let's try another example. This time I have the parent function f of x is equal to x squared. And then my new one, h of x is equal to 3, parentheses, x plus 1. Whoops, we should have a squared on there. And then minus 2. All right, so we need to talk about what has changed about this graph. So the second one is in our vertex formula. So I'm going to pull these guys. Remember that this guy should be your vertex. In the parentheses, it's the opposite of what it's written. So it should be -1, -2 for my vertex. And then this 3 out in front, we talked about that. That's our a value. And since it's a 3, it's going to make it really narrow. All right, so let's see what this graph is going to look like. So I'm going to make this guy over here, make it sort of tall for us. First thing I'm getting graphed on there is my parent function, 0, 0, over 1, up 1, and over 2, up 4. getting all my dots on there, playing connect the dots. All right, after I do that, again, my new one has a vertex at -1, -2. So I'm taking my vertex and putting my new dot right there. Because of the 3, usually I go over 1 and up 1. But instead of going over 1, up 1, I'm going to multiply this guy by the number that's out there. So I'm actually going to go over 1, up 3. 1 and 1, 2, 3. I'm going to do its mirror image. Then I usually go over 2 and up 4, but again, with that number out in front, changing that vertical, we're going to multiply it by 3, so I should go up 12. I don't know if I'm going to have enough room. We'll see. There's over 2, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, and 12. All right, and then I'm going to do its mirror image on the other side, and this graph has become very, very narrow, and it moved. All right. So again, narrow compared to the parent function, and it moved to the left 1 and down 2. All right, our last one for graphing today, again, we have our parent function that we're going to start with, and then we have one that's in standard form, and this is the one where we need to find our vertex first. Okay, so we're going to use that vertex formula of x equals -b over top of 2a. Again, your a is right here in front, we got your b, and we got your c. So if I plug stuff in, my b is already negative, so when I plug it in, it's going to be +6 divided by 2 times my a value right in front. This is just a 1. So I really have 6 divided by 2, which is 3. Again, that's my x value of my vertex, but then I also got to figure out what my y value is, and in order to do that, you just plug it back in. So I'm going to plug 3 in where I see x. So it would be 3 squared minus 6 times 3 plus 1. So that would give me 9 minus 18 plus 1. 9 minus 18 is -9, plus 1 would give me -8. So it looks like my vertex is at 3, -8. All right, so when I go to graph this, make my parent function look. There's my parent, 0, 0, 1, 1, 2, 4. Again, that should be coming pretty quick as you start graphing these because you're always going to have your parent function on there. And then my new one, vertex at 1, 2, 3, and -8. 1, 2, 3, 4, 5, 6, 7, 8. All right. Nothing has changed about the shape because if I look right here, my a value is 1. So I'm still going to go over 1, up 1. I'm going to go over 2, up 4. 1, 2, 3, 4. All right. And then I am going to play connect the dots. And there we have it.